Writing linear equations. So one of the skills we're going to be focusing on is how can we write an equation given information. And in this presentation, we're just purely going to talk about how to write linear equations. And we're going to be writing linear equations provided a point on the line and the slope. But before we dive into the example problems, let's just go ahead and revisit our most critical form, if you would, for doing this process, which is going to be slope-intercept form. Now again, it's referred to as slope-intercept form because the m value represents the slope and the b value represents our y-intercept. Now, there are different forms for lines. There's point-slope form and there's just the equation of slope in general. And there's standard form. However, we're going to utilize slope-intercept form to do all of our problems, whether we're given slope and a point or if we're given actually 2 points, which is going to be in a later presentation. But the integral part is, remember, that in order to utilize this form, we need to know the slope and we need to know the y-intercept. So it's nice for us in these problems because we're already given half the information. We're already given the slope. But now we need to come up with the y-intercept. So if we look at our equation, we could say that y, let's actually change to blue, y equals m, negative 3/5 x plus b. But remember, we need to find the y-intercept or determine what the y-intercept is. So what that means is if I need to calculate b, I have to have values for x and y. And that's where the point comes into play. We have our x value and we have our y value. So what I can do is I can substitute these points in. Negative 2 goes in for the y. The slope stays the same. My x value ends up being 5, and then plus b. Now that's a really good scenario for us because now I have one equation with just one unknown, the b value. In solving this, I'm going to go ahead and take negative 3/5 times 5, which gives me negative 3. And then I'm going to add 3 to both sides to give me 1 for my b value, or in other words, my y-intercept is 1. Now keep in mind, we need to write the linear equation, so I'm actually going to write y equals negative 3/5, because that was provided for us, and now I have my b value of 1. Now, one of the things to point out here is realize that in the formula, yes, it does say mx plus b, but realize that if I were to calculate a negative y-intercept, this would be minus the b value. All right, something unique happens in the second problem here is that we are still given a point and the slope, but the slope in this case is referred to as undefined. Undefined. So maybe we got to go back a little bit. How is something undefined? Well, something's undefined whenever you're dividing by 0. So what this is going to tell me is I should have a fraction somehow in my slope, and the denominator should be 0. Well, if the denominator is 0, that's how the undefined comes, but the numerator, we also know what the numerator is because we know that in the slope, that is our change in x, or x2 minus x1. So what this is telling me in this case is that there is no change in x, or the change in x is irrelevant, my change in y is 0, meaning that the y value is staying consistent the entire time. So what that would look like is, in order for me to get that, another point on that line would just be, let's just make it 1, 3. And if I check myself, this would tell me that my slope would be 3 minus 3 over negative 4. Oh, 1 minus negative 4. Oh, but wait a second. Wait a second, that's right. That's not necessarily correct because our slope equation isn't change in x over change in y. It's the change in y over the change in x. So therefore, the x change must not occur. So that means my x values would have to be the same. So that means I'd have a negative 4 and then just make it 1. And without doing all the math, we would see that that would still be consistent. So long story short, this is telling us that the y values are changing, but the x value is not changing. So what does that actually look like? Well, what that's going to look like is actually a vertical line. So if I have a vertical line here, 1, 2, 3, 4. Oops, let's just make that a solid line. There's my vertical line. So this is a really unique situation here because technically it's not going to look like our slope-intercept form. We're not going to have a y and a number times x plus a b because we can see in this case there is no y-intercept. So this special scenario has the equation x equals -4. So that is the one really unique situation, and we're going to be able to tell that's going to happen whenever our slope is undefined. Now I'll give you one more real quick one. If we have a slope of 0, now a slope of 0 would mean that we have 0 over something, which means that our vertical change isn't changing. So then that would be a horizontal line. So those are the two unique scenarios. If we see a 0 for the slope or an undefined for the slope, realize you'll either work with a vertical line or a horizontal line.